Why do apes like to spin? Maybe for the same reasons as people. Videos of both captive and wild non-human primates suggest an enjoyment of the dizzy buzz that comes from whirling in circles. In 2011, a gorilla named Zola gained internet fame when the Calgary Zoo posted a video that showed him spinning in circles on his knuckles and heels with what appeared to be a huge grin on his face. Zola, the so-called break-dancing gorilla, returned in 2017, this time in a video showing him whirling around a kiddie pool with a level of wild enthusiasm rivaling the most committed human dancer at an all-night rave. Humans' love of spinning around in circles, especially during childhood, is evidenced by the enduring popularity of playground merry-go-rounds, revolving fun park rides, and the irresistible draw of somersaulting down a hill. But new research suggests that humans are not alone in their pursuit of spin-induced buzzes. According to findings published last month in the journal Primates, other great ape species also seem to regularly enjoy stimulating their senses through spinning, possibly even in pursuit of altered mental states. Spinning around to make ourselves dizzy is something we usually think of as a distinctly human activity, said Marcus Perlman, a cognitive scientist at the University of Birmingham in England and an author of the study. So it's really cool to find that other primates do this too, and that they seem to do it for the same reason that children do, because it's fun and exhilarating. After Dr. Perlman saw the videos of Zola, he turned to YouTube to investigate whether other apes engaged in the behavior. He amassed nearly 400 videos showing great apes and other primates engaged in spinning behaviors, including somersaulting, rolling down hills, backflipping, and pirouetting. But the new paper focuses on clips of apes spinning on ropes or rope-like materials. Dr. Perlman and Adriano Lamera, a primatologist and evolutionary psychologist at the University of Warwick in England, found 132 instances of rope spinning across 40 videos involving orangutans, gorillas, chimpanzees, and bonobos. The videos mostly featured captive apes, but several involved wild mountain gorillas on vines. The researchers calculated the speed at which the apes spun. Most of the apes, they found, spun at an average rotation velocity of 1.43 revolutions per second, a speed rivaling professionally trained human dancers and aerialists. The longest spin session lasted 28 revolutions, and the fastest, achieved by a bonobo, clocked in at a brain-scrambling 4 revolutions per second. The researchers observed that the longer an ape spun, the more likely it was to show signs of dizziness, such as letting go of the rope and immediately sitting or lying down. Apes tended to repeat the process of spinning and stopping, engaging in an average of 3 bouts of spinning per session. The animals also often made play faces while spinning, Dr. Perlman said, implying that they were most likely having fun rather than only seeking a way to relieve themselves of boredom in captivity. There's something about the experience they enjoy, Dr. Perlman said. Catherine Hobater, a primatologist at the University of St. Andrews in Scotland who was not involved in the research, concurred. Based on her observations in the field, she said, wild apes love to spin. Apes and some other animals are known to engage in other activities that can scramble the senses, including consuming fermented fruits containing alcohol and ingesting naturally occurring psychedelic substances. Whether this is done on purpose or by accident is debated, Dr. Perlman said. But studies such as this one can begin to provide data needed to explore behaviors that may be evolutionary precursors to the human desire to experience altered mental states. Dr. Perlman is planning a larger study that will analyze hundreds of additional videos of non-human primates spinning. He has also started collecting evidence of other species, including grizzly bears and pandas, that appear to enjoy activities that may make them dizzy. Mark Bekoff, an emeritus behavioral ecologist and cognitive ethologist at the University of Colorado, Boulder, who was not involved in the study, said researching such behavior was valuable because there's no a priori reason to think we're the only animals who engage in behaviors that intentionally produce altered states of consciousness. He added, systematic research will help us learn more about the taxonomy of getting high and not run around thinking we're all that unique. Great apes reach momentary altered mental states by spinning. Abstract. Among animals, humans stand out in their consummate propensity to self-induce altered states of mind. Archaeology, history and ethnography show these activities have taken place since the beginnings of civilization, yet their role in the emergence and evolution of the human mind itself remains debatable. The means through which modern humans actively alter their experience of self and reality frequently depend on psychoactive substances, but it is uncertain whether psychedelics or other drugs were part of the ecology or culture of pre-human ancestors. Moreover, non-human, great apes in captivity are currently being retired from medical research, rendering comparative approaches thus far impracticable. Here, we circumvent this limitation by harnessing the breadth of publicly available YouTube data to show that apes engage in rope spinning during solitary play. When spinning, the apes achieved speeds sufficient to alter self-perception and situational awareness that were comparable to those tapped for transcendent experiences in humans, e.g., Sufi whirling, and the number of revolutions spun predicted behavioral evidence for dizziness. Thus, spinning serves as a self-sufficient means of changing body-mind responsiveness in hominids. A proclivity for such experiences is shared between humans and great apes, and provides an entry point for the comparative study of the mechanisms, functions, and adaptive value of altered states of mind in human evolution. Introduction. Seeking altered mental states is seemingly a human universal, historically and culturally. Slingerland 2021. By Were et al. 2022. The biological and behavioral precursors of such experiences are, however, unclear. McKenna 1992. Pollan 2019, notably because it is challenging to confidently confirm if substance use was viable within the highly diversified ecological and cultural human paleobackdrop. Bergster M. et al. 2021. Whether altered state experiences within the hominid family shaped the emergence and evolution of the modern human mind remains one of the major and most thought-provoking unknowns in cognitive science. Wild primates consume fermented foods with alcoholic content, reviewed in Hawkins et al. 2015. Amato et al. Consumption of these foods typically depends on natural availability and the opportunistic use of scarce resources. Hawkins et al. 2015. Though consumption of fermented foods by primates suggests that they may indeed experience drunkenness, consumption may be primarily driven by the high caloric content of alcohol, and thus a side effect and unavoidable consequence of frugivory. Hawkins et al. Medical research has also focused on drug and alcohol-related behaviors in primates. Grant and Bennett 2003. Wackford et al. 2018, but has primarily focused on substance abuse and addiction, where subjects are externally administered these substances. Evolutionary interpretation is, thus, tenuous at best. Here, we propose and explore the use of a new comparative behavioral model for the study of proactive divergence from normal waking states in human evolution. The act of spinning. Apart from sensing sound, Gazanfar and Hauser 2001, the vertebrate inner ear monitors and senses changes in body motion, orientation, position, and velocity. Lowenstein 1948. Spinning, i.e., rapidly rotating around one's body axis, mechanically disrupts inner ear homeostasis and sends nerve signals to the brain that conflict with those from automatic eye movements. Nigmatulina et al. In humans, this neuronal cross-signaling prompts the perception of a whirling world, along with dizziness, lightheadedness, head rushes, vertigo, elation, and other altered states of perception, mood, and consciousness. Averting these symptoms when spinning at high or sustained speeds requires extensive dedicated training, professional dancers, circus performers, astronauts. More generally, in untrained neurotypical humans, spinning is proactively tapped for rapture, by means of playground spinner bowls, merry-go-rounds, carousels, and collective or spiritual experiences, by Sufi whirling dervishes. In autistic children and adults, spinning is also used as a self-stimulating behavior to control sensory input or intentionally block out external input. British National Autistic Society. Homology in Inner Ear Anatomy Among Hominids, Quam et al. 2015. Braga et al. 2017, and relatively similar body size among primates, suggest that similar spinning behaviors may engender similar neurophysiological effects in non-human great apes, hereafter, great apes and humans. Thus, ancestral individuals, irrespective of whether they had access to psychotropic drugs, may have had the ability to self-induce altered states of proprioception and awareness by spinning. Methods. To test and provide a proof of concept for the assumption that spinning induces altered mental states in great apes, and potentially did so as well in human ancestors, we searched YouTube, Alphabet Inc. for publicly posted and publicly available videos of great apes spinning. We used image-based measures to quantify rotational speeds and rotational duration. See supplementary methods. We focused on rope spinning. Burnett et al. 2017.